FastMCP 3 implements scope-based authorization through a callable-based system that verifies OAuth token scopes at the component level. The framework uses the require scopes function to enforce access control, ensuring that only requests with the specified scopes can interact with protected components. In the upcoming code, you'll see how a FastMCP server is initialized with scoped tools, where each tool is decorated with require scopes to restrict access based on the presence of specific OAuth scopes in the authentication token. The example demonstrates both single scope and multi-scope requirements, showcasing how authorization logic is applied to individual components.
From FastMCP, import FastMCP. From FastMCP server auth, import require scopes. MCP equals FastMCP scoped server. At MCP, toolauth equals require scopes admin. Def admin operation, SDR, requires the admin scope. Return admin action completed. At MCP, toolauth equals require scopes read. Write. Def read write operation, SDR, requires both read and write scopes. Return read write action completed.
This code demonstrates FastMCP 3's scope-based authorization using the require scopes auth check. The pattern shows how to restrict access to tools based on OAuth scopes, with two key implementations: a single scope requirement admin and a multi-scope requirement read and write. The require scopes function enforces AND logic, meaning all specified scopes must be present in the access token for authorization to succeed. The approach leverages FastMCP's component-level authorization system, where auth checks are applied via the @MCP tool decorator's auth parameter. This design allows fine-grained control over tool visibility and access, with unauthorized components being hidden from list responses. The pattern is particularly useful for implementing role-based access control in MCP-compliant servers, where different operations require different permission levels. The trade-off here is between security granularity and complexity. While scope-based authorization provides precise control, it requires careful scope management and token provisioning. The AND logic ensures strict security, but may be overly restrictive for some use cases where OR logic would be more appropriate. In production, you'd need to ensure your OAuth provider issues tokens with the correct scopes for each user role. Let's break it down.
From FastMCP, import FastMCP.
Imports the FastMCP class from the FastMCP module, which is the main class for creating MCP model context protocol server instances. The imported class will be used to instantiate a server with a specific identifier label.
From FastMCP server auth, import require scopes.
Imports the require scopes function from the FastMCP server authentication module, which provides scope-based authorization checks for OAuth tokens.
MCP equals FastMCP scoped server.
Creates a FastMCP instance with the server identifier, scoped server. This string serves as a label for the server that will appear in MCP protocol handshakes, allowing clients to identify this specific server instance. The identifier does not configure any functional behavior or operational mode.
At MCP, toolauth equals require scopes admin.
Decorates the function with @MCP tool and enforces admin scope authorization via require scopes admin. This restricts access to the tool, allowing only requests with the admin OAuth scope to invoke it.
Def admin operation, SDR, requires the admin scope.
Defines a function named admin operation that returns a string and includes a docstring indicating it requires the admin scope for authorization. The docstring serves as metadata that FastMCP will use to enforce scope-based access control when this function is registered as a tool.
Return admin action completed.
Returns a string literal admin action completed as the result of the function execution. This serves as a simple status message indicating successful completion of an administrative operation.
At MCP, toolauth equals require scopes read, write. Def read write operation, SDR, requires both read and write scopes.
Decorates the read-write operation function as an MCP tool that requires both read and write OAuth scopes for authorization. The decorator uses require scopes to enforce that the caller's token must contain both specified scopes, with and logic meaning both must be present. The function's docstring explicitly states this dual scope requirement, which FastMCP will use as the tool's description when registering it.
Return read write action completed.
Returns a string literal indicating successful completion of a read-write operation. FastMCP3's scope-based authorization ties directly into its component-level security model through the require scopes auth check. By decorating tools with @MCP, toolauth equals require scopes, you're applying strict and logic to OAuth scope validation. All specified scopes must be present in the token. The pattern scales from single scope requirements like admin to multi-scope combinations like read and write, with each tool's docstring serving as both documentation and metadata for access control. This design enables fine-grained RBAC where tools become invisible to unauthorized clients, but requires careful scope management in your OAuth provider. The trade-off is clear: precise access control at the cost of increased token provisioning complexity.
The require scopes. Gate swings wide, yet tokens slip through like whispers in the dark.